We'll talk about work today. Work in physics is a kind of a strange thing. I guess the easiest way to start off is to tell you how it's defined. W is for work, equals force times displacement. Okay, that's the formal definition of work in physics. Force times displacement. And the unit of work is the joule. Joule is how you spell joule. And its symbol is a capital J. Okay, what is a joule equal to? Well, a joule, well, if you think about it, we got newtons and meters, is a newton meter. And sometimes you see it listed as newton meters, but it's just a joule. Work is force times displacement, like we just said. There's kind of a tricky thing though. Say that we have a box and maybe we move the box to over here. Okay, we moved the box, and we move the box by applying a force to the blocks like that. Then we would have done some work. You know, maybe a certain distance, a certain force. We've got work. The issue is that work only actually happens. Let me write this. I'm going to put it up here. Work is only done when the force on an object is in the same direction as the displacement. And you might say, well, when would it not be? Well, situation where maybe, let's move that. For instance, if we have a box and it's moving this way, but you push this way, so there's your force and there's your displacement, it ends up over here, but you pushed that way, but it didn't move the box that way, it only moved east and west, as it were, then you wouldn't have done any work. There has to be movement, displacement in the direction of the force for work to happen. That's the key. So let's consider a situation similar to some of the vector problems we worked before, where maybe there's a box and here you are and you're pulling on the box with all your might with a rope tied to the box. There's your rope. Okay. And the force you're exerting is this way, but the box moves. I'll use blue for where the box ends. The box ends up over here. Okay, so the direction is this way, but your force is that way. So if we want to know how much work you did, well, remember the force has to be in the same direction as the displacement. So what we'd have to do is we would have to figure out the x component of the force. We would need the force in the x direction. Well, we hopefully remember that the x component of a force equals F cosine theta. So when we do W equals FD, well, what we really want is just the x component, so that's pretty easy. It's going to be W equals F cosine theta times D. And sometimes you'll see FD cosine theta. And hopefully that's going to be a pretty easy thing for you. Just remember that if the force is exerted at some angle, and you take the cosine of the angle in between the force and the displacement before you can calculate work. And it's not hard. So that's basically it on work. If you want to stop this video now and go look at the first few problems on the classwork today, there's going to be your work problems. That's not all we have to do today, so make sure to come back and resume the video. But if you want to do that, go ahead. Next we're going to talk about power as it relates to physics. Power is just the rate of work. The rate of doing work. And it's very simply defined, P for power equals work over T for time. Work divided by time is power. And that would be, if we were talking about units, that would be a joule per second. But what we don't call it a joule per second, we call it a watt. And the symbol is just a capital W for watts. Okay. There's really not much to say about that. Just if you're asked to calculate power, or if, just this fits together with W equals FD, we could get real crazy with it and say that P equals FD over T if we wanted. Just another formula. There are a couple of power problems in your classwork for today, so if you want to go give those a try before you move on, it might be a good idea.